Hello everyone, I am Godwin Paulson Pichaimani. I am a professor in Asiatic Command, IPN, Mexico City. And here I have Mr. Sudarshan Sandana Krishnan with me, and we are going to talk about Beyond Earth. It's a season 1 and the episode 1 is Introduction to Remote Sensing. Hi Mr. Sudarshan, can you tell about yourself?
Thank you, Doctor. I am Sudarshan Santanakrishnan, pursuing doctorado in sciences at CIIEMAD in IPNA. My line of investigation is disaster management and climate change using remote sensing and GIS and instrumentation engineering.
Well, in today's episode, we are diving into two fascinating technologies, remote sensing and geographical information system. These two technologies are transforming how we understand and interact with the world around us. But what exactly are they? Well, that's what we are going to explore today.
Exactly, Doctor. A lot of people may have heard this theme before, but might not really know what they mean or how they work. So let's start from the very basics. What are GIS and remote sensing?
Yeah, well said. Let's begin with GIS, Geographical Information System. As the name says, systems, information, and geography. System which contains computer and softwares. The information is data and the geographic is location. GIS is a framework for gathering, managing, manipulating, and analyzing data that's linked to a specific location on Earth's surface. It's essentially like a map, but it's much more powerful. It doesn't just show where the things are, it also helps us understand the patterns between different layers or different things on the Earth, relationship between different entities, and trends on Earth's surface based on the dataset.
Well, Doctor. Remote sensing is the process of detecting and monitoring the physical characteristics of an area by measuring its reflected and emitted radiation at a distance, typically from a satellite or a aircraft. Special cameras collect remotely sensed images, which helps researchers sense things about the Earth through sensors. For example, remote sensing can involve capturing things like temperature, moisture, and vegetation health all from a distance.
Exactly, Sudarshan. Remote sensing provides the data, and GIS is a system which is used to process and analyze the data. Often, it will help us to visualize the data on a map. It's like the two things work together to give us a deep understanding of the world's processes.
So now that we know what they are, let's talk about the history. How did GIS and remote sensing evolve, Doctor?
Great question, Sudarshan. GIS as a formal field started in the year 1960s thanks to an English Canadian geographer, Roger Frank Tomlinson. He is often called the father of GIS because he developed one of the first systems to manage and analyze the geographical data. It was originally used for land use planning in Canada.
That fascinating. And the history of remote sensing began in the 18th century with photograph and camera obscure. It has since evolved to include satellites, aircraft, rockets, and other platforms. The photographs in 1858 took by G. Thornton, Alice Nadar, took photograph of Paris from a hot air balloon, which extended in the World War I. The aerial photograph was used for military surveillance and reconnaissance, which followed in World War II also under the development of radar, sonar, and thermal infrared detecting systems.
Yes, over the years, the technology has advanced drastically. GIS evolved from desktop systems into fully integrated, powerful software platforms, while remote sensing technology has also grown. The first artificial satellite was Sputnik 1, which was launched by the Soviet Union on October 4th, 1957. These satellites were primarily sent to explore the possibilities of placing a satellite in its orbit and to explore the atmospheric components of Earth. And remember, the first satellite was sent by the Soviet Union, and then in 1958 the Earth Explorer satellites from America was sent.
Thank you, Doctor. Thank you for lightening some history and evolution of GIS and remote sensing. Now, can you explain how GIS and remote sensing works?
Yeah, let's break down how these systems actually work. For GIS, it's all about data layers. And while talking about data layers, there are two kinds of data. One is vector data and the other is raster data. For example, the vector data contains point data, line data, and polygons data, like the population data or point data, the rivers and road networks or line data, and the boundaries of each municipality and the states were polygon data. And raster data are images or pictures from satellite, and these layers can be incorporated in GIS, and each layers contain information about a particular aspect of the area.
Right, Doctor. You can then analyze the relationship between those layers. For example, you could look at how traffic patterns intersect with the air pollution levels, or examine how land use affects biodiversity. All this is possible because GIS combines spatial data with attribute data, as you explained previously, allowing for deep analysis.
Yes, Sudarshan. Like the vector data, the principles of remote sensing are collecting information involves detecting and measuring electromagnetic radiation reflected or emitted from the Earth's surface at different wavelengths, allowing for the identification and categorization of objects or features on the ground without having direct contact, typically using sensors or satellites or aircrafts to capture the data. When we talk about the reflectance of electromagnetic radiation, each place or each object on the Earth's surface is having different spectrum of reflection. Using this electromagnetic reflectance, the sensor can detect the various objects from Earth's surface.
Yes, doctor. By using this electromagnetic spectrum as a medium to recognize and utilize the various wavelengths of electromagnetic spectrum, including visible light, infrared, microwave, and radar, each provide different information about the surface. And based on that, we can characterize surface of the Earth.
Yes, and also there are five components of remote sensing systems which are very important. The primary source is the sun because sun provides energy to collect information from the sensor. And the second one is the target area or the area on the Earth's surface which is being observed. And the third one is sensor. The sensors are the devices that capture the reflected energy from the Earth's surface, such as camera or radar. And the fourth one is receiver station, where we can receive the information or we can collect and store all the data from satellite. And the fifth one is laboratory, where we can analyze and interpret the data.
Finally, the obtained data have four kind of resolution: spatial resolution, spectral resolution, radiometric resolution, and temporal resolution. The spatial resolution is the smallest area on the ground that can be distinguished by the sensor, determining the level of detail in the image. Spectral resolution, the ability of the sensor to distinguish between different wavelengths of radiation. Radiometric resolution, the sensitivity of the sensor to detect variation in brightness level. And finally, the temporal resolution, the revisiting time of each satellite to collect the information of a particular location. Now, doctor, what are the some of the advantages of using GIS and remote sensing? Can you please explain?
Yes, Sudarshan. For starters, Efficiency is a huge factor. GIS allows you to manage and analyze vast amount of data in one place. It makes tasks that would take forever by hand, like mapping a large areas, with GIS is much quicker and is more accurate because when we collect information or when we collect photographs of a large area, we can analyze with your own eyes. So that GIS allows you to make more zoom on a particular area, and with the help of multispectral bands, it helps us to analyze and we can interpret more data using the GIS.
Yes, doctor. And remote sensing gave us the ability to capture data from inaccessible areas. For example, you can monitor environmental changes in remote forest, oceans, or even volcano without any physical contact. It's safer and much cheaper than sending a human in dangerous environment.
Exactly, Sudarshan. Another big advantage is monitoring over time. With satellite images, we can track changes in the environment over decades. That is, continuous monitoring is possible, which is invaluable for things like climatic studies, urban planning, and disaster management. For example, the satellites like Landsat, which provides information from 1970s up to now. So we have images from 1970s to 2025, which helps us to understand the changes in Earth's surface over the past 4 or 5 decades. And now we will move on to application section. There are so many areas where GIS and remote sensing are used. For instance, or for example, the geology. The remote sensing is used to map the landslide susceptible zone and to identify the earthquake risk zones. Also, GIS used to monitor the subsidence at different locations. And in the field of biology, remote sensing helps us to identify species. It helps us to manage the wetlands. It helps us to track wildlife animals, and also we can monitor or observe the movement of wildlife animals. And in the field of environmental management, we can use remote sensing to monitor the changes in forest areas, for example, the deforestation level. And also, we can identify the pollution level in urban and rural areas. And more than that, we can monitor the habitat loss.
Yes, doctor. They are also crucial for disaster response. After a natural disaster like a hurricane or a earthquake, remote sensing can give responders real time data on damage, allowing them to deploy resources more effectively. Now, can you please explain how about the applications work in the agriculture field?
Yeah, it's a good question, Sudarshan. Farmers, for example, they can use GIS and remote sensing for precision farming. They can monitor crop health, soil moisture, and they can predict the harvesting yields with the help of satellite images and also with the help of images collected from drones. It helps them to optimize the use of resources like water and fertilizers because these images from drones or satellites can help us to identify the changes in crop health from day to day or from month to month. Based on that, they can limit the water resources and fertilizers.
Well said, doctor. And also, we don't forget about the defense and military applications. Remote sensing is used for surveillance, monitoring borders, and understanding the terrain for strategical purposes.
Absolutely. The applications are vast and we can keep on talking about this. For example, in public health, for tracking the disease outbreaks, to climate science, where researchers are using these technologies to monitor glaciers, sea level rise, and carbon emissions.
Great, doctor. Could you please share a few words about one of your research projects where remote sensing and GIS play a crucial role?
Well, we are doing a project myself and my student from Asyati Common, Monse, to identify the vulnerability of heat waves for throughout the Mexico. And the main objective of this research is to identify the areas of vulnerability and also to generate a heat vulnerability index for Mexico. And we have used four types of data: exposure data, sensitivity data, and adaptive capacity data to generate a vulnerability index. The exposure data, for example, is the temperature data and also the population density data or exposure data, because population is directly exposed to temperature. And sensitivity data we can call like the population who are more sensible to the risks or the vulnerabilities. And the adaptive capacity data is the population who has the capacity to adapt during these vulnerable events. And we have used one technique, the mathematical technique, which is the principal component analysis, because there are more than 15 parameters we have used to generate an index, and we don't know which index or which parameter has more weightage.
Mm.
To give this weightage for each parameter, we have used principal component analysis. And with the results from principal component, we have assigned weightage of each parameters, and then there are formulas for calculating the index, and we have used these formulas for generating vulnerability index for the whole Mexico for each municipality.
Wow, it's fascinating. It's clear these technology play a massive role in how we understand and interact with the world. It's crazy to think about how much data is being collected and how it's transforming industrialized and all over the globe.
Yes, Sudarshan, we have collected huge data because it's for the whole Mexico. We have used more than 15 parameters, the physico-chemical parameters, the climatological parameters, and it's a huge data. And the best part is both GIS and remote sensing continues to evolve. As the technology improves, we are only getting better and better at understanding the earth, making decisions, and tackling the global challenges. Well done. Let's wrap this episode. We hope this gave you a clear picture of what GIS and remote sensing are all about. And thanks for tuning in.
Thank you, Dr. Godwin, for sharing your valuable and wonderful work you are doing. We will catch you next time with another deep diving into the tech shaping our world. Until then, stay curious.